Welcome to our next video. It is Dr. D.BHAKIARAJ, working as an assistant professor in Department of Chemistry, St. Joseph's College. In this video, we are going to see what is ZWITTER ion and isoelectric point. So first, what do you mean by ZWITTER ion? Let us consider amino acid. What do you mean by an amino acid? Amino acid are nothing but the organic compound in which both amine group and carboxyl acid group present in the same molecule. Any organic compound, if the amine group and carboxyl acid groups are both the groups present in the same molecule, then those compounds are called amino acids. Normally, amino acids are colorless crystalline solids and their melting points are above 200 degree, and mostly they are soluble in water, but some cases it is insoluble in non-polar organic solvents. There are properties of the most carboxylic acids and amines. They will show the properties of carboxylic acid in some cases and amine group in some cases. The reason for this anomalous behavior is that amino acids contain both acidic carboxyl group and basic amine group in the same molecule. In aqueous solution, the acidic carboxyl group can lose a proton and the basic amine group can gain that proton in a kind of internal acid-base reaction. So in the structure you can see the amino acid. From the carboxyl group, the oxygen withdraw the bonded electron towards itself because of its higher electronegativity, and it loses the H plus ion as a proton. So this will happen in the case of aqueous solution, and the amine group on the other side absorbs the proton and converted itself as a positive ion. So the product of this internal reaction is called dipolar ion because both the negative polarity and positive polarity, both are present in the same molecule. In aqueous solution, one proton from carboxylic acid releases and one proton attaches to the amine group and converted into a amino cation. So this kind of dipolar ion in which both positive ion and negative ion present in the same molecule is called ZWITTER ion. ZWITTER ion. Although it is neutral overall, it contains both the positive and negative charge. Amino acids in the dipolar ion form are amphoteric in nature. That is, they react in both acids and bases. So the reaction with the base converts the amino substituent into a amine group. The reaction with the acid converts the carboxylate substituent to a carboxyl molecule. Thus, in acidic solution, the amino acid exists as a positive ion, and in basic solution, the amino acid behaves as a negative ion. In amino acid, in acidic solution, it attaches one proton with it and converted into a positive ion. Similarly, on the other hand, the amino acid in basic solution, from the basic solution OH minus ion produced, that OH minus ion attract that extra proton and convert it into a negative ion. So these kind of ions are called ZWITTER ion. Then what do you mean by isoelectric point? In amino acids, we know both the ions are present in the same molecule. Because of this ZWITTER ionic or dipolar ionic character, in acidic solution, it behaves like one side, and the basic solution it behaves on the other side. That is, the negative ions normally migrate toward the positive electrode in the electric field. On the other hand, the positive ions, which is nothing but the cations, migrate toward the negative electrode, that is towards the cathode in the electric field. A neutral molecule is attracted neither of the electrode and behaves as a neutral. So, in the case of amino acids, in acidic solution, the amino acid exists as a positive ion. So, in acidic solution, it migrates towards the cathode. On the other hand, in basic solution, the amino acid exists as a negative ion and migrates towards the anode. So here we can able to maintain the pH of the electrolyte solution in such a way that the amino acid will not move to either of the electrodes. That particular pH is specific for each and every amino acid. So at a certain pH, that is at a certain hydrogen ion concentration, the amino acid molecule will not migrate to either electrode and exist as a neutral dipolar ion. This particular pH value is called isoelectric point of the amino acid. So look at the structure. So here the amino acid in acidic solution, it behaves as a cation, because in acidic solution the carboxylate and converts into carboxylic acid. Because of that, only NH3 plus is there. That is why it behaves as a cation and moves towards the cathode. But in the case of basic solution, you can look at the diagram on the right side. In basic solution, because of the presence of OH minus ion, one proton absorbed and the NH3 plus converted into NH2 amine group. Hence, only the COO minus carboxylate ion alone is there and it behaves as a negative ion. Because of this behavior of the anion, that amino acid will move towards the anode in the electrolyte solution. Now, we have to maintain a pH in such a way that the electrolyte solution's pH such a way that the the amino acid will behave as a neutral molecule and it will not move either side of the electrolyte solution. So that particular pH value is called the isoelectric point of the amino acid. As I told earlier, it is specific to one compound to another compound. So all the amino acids do not have the same pH value for the isoelectric point. So in generally, the neutral amino acids have isoelectric points from pH 5.5 to 6.3, and the acidic amino acids have isoelectric point at a low pH, that is around 3, and the basic amino acids have isoelectric point at a high pH value, that is at around 10. So hope this video is useful for you. Thank you.